Los Angeles at the same time. One heads south to San Diego while the other heads north to San Francisco. So we have planes, they're going in opposite directions. The San Diego plane flies 50 miles per hour slower than San Francisco. In 1/2 hour, they are 275 miles apart. So we know their total distance of 275. When we had this, we made a table to organize lots of information. We put our formula across the top. So in this case, we're doing rate times time equals distance. And we also use this with like our mixture problems, the amount times concentration equals amount pure. Then we labeled, so we have San Diego and San Francisco. And we fill in the blanks. So San Diego is 50 miles per hour slower than San Francisco. Okay, it does not matter which one, but one of these has to be X. Which one did you guys pick? Okay, if San Francisco is X, San Diego is 50 miles per hour slower, so it would be X. The other option, you could make San Diego X, and San Francisco would be X plus 50. So you can do it either way, that's why we write a sentence at the end. Time has to be measured in hours, so it's 1/2 hour or 0.5. And then we do the formula, rate times time equals distance. So 1/2 times the x minus 50, 1/2 times x. We know their total distance is 275 because they're going in opposite directions. We just have to add that up to equal our total. So 1/2 times the x minus 50 plus 1/2 times the x equals 275. 1/2 x minus 25 plus 1/2 x equals 275. Add like terms, so that would be x, add over your 25, so x is 300. Then what do you have to do at the end? Okay. So my x was San Francisco. So my San Francisco plane flies 300 miles per hour, and San Diego flies x minus 50, so 300 minus 50, 250 miles per hour. Is that okay? So remember, in those scenarios when we have a lot of information, set up a table. Put your formula across the top, and then work from there. All right, problem number 4. So it's a quadratic. We like for our quadratics to be equal to 0. So if we distribute, move everything to one side. So you probably tried slip and slide. X squared minus 2x plus 6. But does anything multiply to 6 and add to -2? No. So when slip and slide fails, you have two options, completing the square or quadratic formula. And I think quadratic formula we probably went with more often. So x equals opposite of b plus or minus the square root b squared minus 4ac all over 2a. So opposite of b would be positive 2 plus or minus the square root of -2 squared minus 4 times 3 times 2 all over 2 times 3. So that gives us 4 minus 24, so -20 over 6. We can break 20 up into a 4 and a 5. Because of the negative, you take out an I as well. So square root of 4 is 2. We can take out an I. We have radical 5 over 6. Is everybody okay to that point? Anything involving an I, we always separated to write standard form. When I do that, I can see these things reduce. 2/6 is 1/3. 2I radical 5 over 6 is I radical 5 over 3. And that would be our final answer. So any quadratic can be solved with the quadratic formula. This one is very similar. It's already equal to 0. When you try slip and slide, you get x squared minus 5x plus 12. Does anything multiply to 12 and add to negative 5? No. So we're back to quadratic formula. Make sure if you're abandoning slip and slide and going back to quadratic formula, it's from the original equation. So opposite of b would be a positive 5 plus or minus the square root of b squared minus 4ac over 2. So we get 25 minus 48 under my square root. So that's a negative 23. If there's a negative, what are we going to have to do? Take out an I, and then we have to separate it because it has an I. So we'll do 5/4 plus or minus I radical 23 over 4. Any questions about using the quadratic formula? We have two options for this problem. One option is to get rid of all the fractions. The other option is to keep them and get common denominators. Which route do you guys want to go? I think most people, when I was helping, were getting rid of the fraction. That seems to be the more common. If you're going to get rid of them or get a common denominator, either way, we do need to factor so we know what they all are. So this is x plus 3x minus 3. So if I want to get rid of this fraction, I have to multiply by the bottom. So I have to take everything times x plus 3 and x minus 3. But if I take one thing, I have to take everything. So those cancel, and we just have a 12 left. Over here, x minus 3 drops, so we have 2 times the x plus 3. On this one, the x plus 3 drops, so minus 3 times the x minus 3. So if we multiply everything out, it gives me a negative x plus 15. Subtract that over and divide, so we get x to be 3. But my answer said no solution. Why? When we did these problems, a lot of times I would tell you, go out to the side and tell me what x can't be. Because we know in a fraction, the bottom can't be 0. So what makes x minus 3 equal 0? And x plus 3? So if I get positive 3 or negative 3, I can't have that. So when I go to check this, I have something divided by 0, which we know does not work. So you either need to make a note to yourself at the beginning what x can't be, or just check your answer at the end. When you get a divided by 0, you know we can't have that, so it's no solution. Any questions about that one? Were you guys okay on 9 and 10, the absolute value equation, quadratic inequality? Alright, this problem, we again have more than one strategy we can use. We can either deal with the fraction. It's just linear. We have x to the first, so we could break everything up and deal with fractions, or we can get rid of it. Doesn't matter which route we take. What do you guys want to do? Get rid of it? Okay. My denominators are currently 7 and 3. What would you have to multiply by to get rid of all of those? 21. If you multiply, you are taking every single term times 21. Because I'm distributing it to each piece. So here, 21 divided by 7 is 3. So we get a 3x. Minus 3 times 21 is 63. 21 divided by 3 is 7, so 7 times the x minus 4 plus 21. So then we just have an equation to solve, or an inequality. So distribute the 7. Combine like terms. I bring that over, that's a negative 4x. Add over my 63, and that gives us a 56. If you divide by a negative, what happens to the inequality? That's less than negative 14. On a test, all your answers have to be written in interval notation. So less than negative 14 is like saying smaller. Graph is not required, but I just put it up there for a visual so we can see it's negative infinity to negative 14. Problem 13. These we all probably need to review, even if you got it right. These inequalities, it's not that they're so much hard, but you have to think about it a little bit. I want to know when this fraction is less than 0. That means when it's negative. Okay, you cannot just say the top and bottom are both less than 0. Because if you divide two negatives, what do you get? A positive. So what has to happen, I get a negative if one is positive and one is negative, right? So we did this by making a sine line. We had to figure out what would make both the top and bottom equal to 0. Because those are the places where we either have a vertical asymptote or an x-intercept. So those are the places where we can change between positives and negatives. So if I do that, it could be a 4/3 or a negative 5. Okay, now I'm just trying to figure out what this graph would look like. So we did test points. Give me a number smaller than negative 5. Give me a number in between these two. And give me a number bigger than 4/3. And what I'm doing is I'm going to take these numbers, plug them in here, and all I care about is if it's positive or negative. Okay, if I put in negative 6, negative 18 minus 4 is negative. Negative 6 plus 5 is negative. If you take a negative and divide by a negative, you get positive. So that means every number smaller than negative 5 is going to make this inequality positive. If I put in 0, 0 minus 4 is negative. 0 plus 5 is positive. A negative divided by a positive. If we put in a 2, 6 minus 4 is positive. 2 plus 5 is positive. Positive over positive is positive. I wanted less than. What does less than mean? Negative. So this section. Now, equal to means bracket, but both of these cannot get a bracket. Why? The bottom can't be 0. So negative 5 has to get a parentheses just because it came from the bottom of the fraction. 4/3, the top can equal 0. So we get negative 5 with a parentheses to 4/3 with a bracket. Does that make more sense? Number 14. F of x is 2x squared minus 1. P of x is negative 3x plus 4. decomposed with g. That means f of g of x. So you start on the inside. G is negative 3x plus 4. I am plugging that into f. So I go to function f, and every time I see an x, I write negative 3x plus 4 instead. Okay, so just like if you were plugging in a number, you start with the inside. Okay. From here, what would I have to do to square that? So we get 9x squared minus 12x, and minus 12x would be minus 24x. 16. Distribute the 2, so we get 18x squared minus 48x plus 32 minus 1, or 18x squared minus 48x plus 30. Are those okay? Are you guys fixing any mistakes you have as we go through? Is this helping us at all? Alright, on this, you should be able to draw the parent and the final transformation. I forgot to tell you, my answer key, the program I was using wouldn't let me do a dash line for my parent function. So I think I did my parent function blue and the final one green. Sorry. It's just, don't shake your head. I was trying to be nice and create the graphs for you. Alright, so parent function, a square root. Can we do the square root of a negative? No. So the square root of 0 is 1. 2 doesn't turn out nice, so the next nice one would be 4. 2, you could do 9, 3 if you wanted another point. I always set a minimum of 3. And what will my transformation do this time? Right, so I take each of these points to the right. And that's my final. We have the absolute value of x plus 4. What's an absolute value look like? Absolute value of 0 is 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. If you don't know, you can always do more points. Just keep making that t-chart to get your graph. Then we have to think about our transformations. What will the plus 4 do? So I take each of these points up. Um, 24. So I wanted the remainder. And I think most of you just did synthetic division. So remember synthetic division. Out here is whatever makes x minus 2 equal 0. So that would be 2. Then we put our coefficients. If you have any missing powers of x, remember you have to put a 0. Okay, so 2 comes down. 2 times 2 is 4. 8 plus 4 is 12. 2 times 12 is 24. What's negative 5 5 is 19. 2 times 19 is 38, plus 5 is 43. You guys remember synthetic division? So I want to know the remainder. Remember when you divide, this is your remainder, this is your constant, this is your x, and your x squared. So my remainder is just 43. How do we know if something is a factor? So not a factor. Hence the remainder is not. Is that one okay? We definitely want to review this one because it would be a pretty high point value question on your final. There is a lot involved here, so quite a few points in this. My polynomial is 4x cubed minus 4x squared minus 7x minus 2. All right, can you tell me how many zeros will this have? 3. How do we know? Okay, x cubed. So on the final, I would probably break this into steps. I would say, okay, tell me all the possible zeros. In order to get the possible zeros, we have to do p's and q's. Where do the p values come from? The constants, everything that goes into -2. So it could be positive and -1, positive and -2. You have to have the plus and minus. Where does q come from? Everything that goes into 4, plus or minus 1, plus or minus 2, plus or minus 4. How do we find the possible zeros? So, 2 over 2 is 1. We already have that. 2 over 4 is 1/2. We already have it. Once we have a list of possible zeros, what do we need to do? Find one that works. Okay, here is an issue that some of you had back when we took this test. You just plugged in every number, so all 8 of those numbers, and told me which ones worked. That does not give you all the answers sometimes. These are only the possible rational zeros. So if you have anything involving a square root, or an I, or if you have a multiplicity, you won't get it by doing that. So we cannot find all of our zeros just by plugging it in. We just use that to find the first one. So if you do that, how do you know if something works? It equals 0. So what made it equal 0? 2. Once you find one that works, you must do synthetic division. If you don't, you are going to miss answers, and that is going to cost a lot of points. So I find one that works, I do my synthetic. So it's 8, -4 plus 8 is 4, -7 plus 8 is 1, and we get 0. Then, we remember this is my remainder, this is constant, x squared. We have 4x squared plus 4x plus 1. At this point, we can factor this. So once you get down to a quadratic, we go back to our normal factoring. Multiply to 4 and add to 4 will be 2 and 2. Undo the slip and slide. So 2 over 4 is 1/2, so we get 2x plus 1 and 2x plus 1. So the question said, find all the real zeros and the factored form. Okay, my zeros. What makes 2x plus 1 equal 0? 1/2, but it showed up twice. Multiplicity 2, and the third 0 was 2 from right here. Then my factored form is 2x plus 1 squared. And what do we do for that 2? Minus 2. So make sure You are showing the work. You have to be able to list possible zeros. Once you find one that works, you have to do the division. If I were just plugging in numbers, I would have got 1/2, but I would not have known that it had a multiplicity of 2. All right. 26. Okay, I told you find the remaining zeros. So I gave you the first one. When you have the first one, you do synthetic. So we're dividing 2i in the box. 1 comes down. 1 times 2i is 2i. Can you add -4 plus 2i? We just bring it all down. Now we multiply it. 2i times -4 plus 2i. So that gives me -8i plus 4i squared. But what is 4i squared? When I add these, the 4 and -4 cancel and we just get -8i. So then we have 2i times -8i, which is -16i squared, and that turns into, and we knew that remainder had to turn out to be 0, because I told you it was a 0. We have something pretty ugly left. I don't really want to try to factor that, but if you have one imaginary 0, what do you know? Okay, the conjugate is also going to 0. So I'm going to do this again with positive, -2i, sorry. And the answer I just got out without the 0. So 1 comes down. 1 times -2i is -2i. When we add, now the i's drop and we get -4. -4 times -2i is positive 8i. Add those and we get 0. So then that's x minus 4. So the question was to tell the remaining zeros. Alright, I already gave you 2i, so you don't have to tell me that again. The other zeros that worked were -2i and positive 4. Alright, is everyone okay with that one? Alright, 27. Why don't you guys get out something to jot down some rules on? Or the back of your study guide, something, because we need to know these asymptote rules. You probably have room on the back. Alright, so the asymptote rules. I want everyone writing this down so you have it. Vertical asymptote is always x equals some number. And it's what makes the denominator equal 0. Horizontal and oblique. We talked about these cases and I gave you the rules, but I also told you you don't necessarily have to memorize the rules. It's kind of like a division problem. It will always turn out to be y equals 0 if the top degree is smaller. So for instance, if I said x plus 3 over x squared minus 4. Okay, if you were trying to divide those, can you do x divided by x squared? No, so your quotient is 0, and then you have your remainder. Okay, the asymptote is essentially what this quotient is, if you ignore the remainder. You're going to get y equals the ratio of leading coefficients if they are the same degree. Okay, what I mean by that? If I set this up as a division problem, my 5x, x squared, sorry, 5x squared minus 1 is in here, 2x squared plus x minus 3 is out here. When you go to divide, can you do 5x squared divided by 2x squared? Yeah. You just get 5 over 2, and then everything from that point on would be the remainder. So our asymptote is that 5 over 2. So if it's the same power on top and bottom, you just divide those leading coefficients. And you could even think of this one the same way, because if there's no x squared on the top, isn't that the same as if I said 0x squared? That's right what I said. So x plus 3 would be the same as 0x squared plus x plus 3. And 0x squared divided by 1x squared is 0. Oblique happens when the top degree is 1 bigger, and you're going to get a line, y equals mx plus b. So when we have something like, x minus 3 over x cubed minus 3 over 4x squared plus 2. If I divide those, we are actually going to be able to get some quotients. So we're going to do an example here in a minute with the questions you guys asked. But you would actually set this up like a long division, and you could even include your missing powers if you needed. And so you would go through and divide. What is x cubed divided by 4x squared? 1/4 x. Okay, then you multiply. 1/4 x times 4x squared would be x cubed. 1/4 x times 2. 1/2 x. And then we always subtract it off. We don't have to do the full division. See here, those cancel, there's nothing here, so I have a negative 1/2 x minus 3. Can I even do 1/2 x divided by 4x squared? No, so in this case, it turns out to be y equals 1/4 x. But we'll do another one here in a minute with question 27. If the top is more than 1 bigger, there isn't a horizontal ordinate. Because when you divide them, you would end up with an x squared or higher, and that's not a line. So if we look at 27. All right, let's factor the denominator. X squared minus 9 will break into x plus 3, x minus 3. So vertical asymptote. These are lines, so you have to give me an equation. What makes the bottom 0? Then we look. What's the degree of the top? X to the first, so 1. What's the degree of the bottom? 2. Can you do x divided by x squared? No, so that's a horizontal asymptote. Y equals 0, because you can't. Does that make sense? We look at B. Vertical asymptote. What makes the bottom 0? Okay, what's the degree of the top? Bottom. So we can divide these. What is x squared divided by x? Then you multiply. X times x is x squared. X times negative 2 is negative 2x. We always subtract this off, so we change our signs. X squared minus x squared is gone. 0x plus 2x is 2x plus 4. What is 2x divided by x? So that is a line, so that's oblique. Y equals x plus 2. So now we're going to use all these rules again to do the full graphing piece. So first thing, we always made sure it was factored. Top, you can't really do anything. Bottom, this would factor into x plus 3, x minus 2. X-intercept. What is an x-intercept? When it hits the x-axis, which means your y is 0. So it's really saying when this fraction equals 0, which is really just when the top of the fraction is 0, right? So then our x-intercept is 0. How do you find a y-intercept? It's when you hit the y-axis, so your x's are 0, and we get 0. So far, I know I hit the x and y axis both at 0. Vertical asymptote. What would it be? So we graph those as dashed lines. Make sure you gave me the full equation. So x equals negative 3 and x equals positive 2. Okay. Horizontal or oblique? What's the degree of the top? And the bottom? So when you're dividing, what is x squared divided by x squared? 1. So that's a horizontal line. Y equals 1. Okay, so from here we had to use our calculator to get some test points to kind of figure out what our graph is going to look like. Because we know we don't have a graphing calculator on the final. I accidentally put graphing. I just didn't use your calculator here. So we picked some test points. So we need to test on each side of these vertical asymptotes. So this one's at negative 3. So maybe I put in a negative 4. You can do it on your calculator. It's not a big deal. So go to that. You can set it up. If you plug in a negative 4, okay, what do you guys get? Everybody has a calculator. You can plug in negative 4 and tell me what you get. Negative 8/3 or positive? Positive. Okay. So it looks like a 2.6. And that's all I really need because I know now I can't cross a vertical asymptote. So asymptotes, we're just approaching them. So this section of my graph is up here. Okay, we can try some points here. If I put in negative 1, I would get 1 over negative 6, so that's a negative. If I put in positive 1, I get 1 over negative 1/4, that's negative. So this section is like an upside down graph. If I put in a 3, I get 9 over 6, so 3/2. So this one is also up here. So you're putting in those test points so that you know which section or where is it above or below that horizontal asymptote. So really all I'm worried about is it higher or lower than 1 when I plug it in. Is that okay with everyone? 29. So this is graphing our polynomials. And I will kind of guide you on those on the test, just like I did here. I'm going to tell you all the things you need to do. So your degree, that's like saying if I multiplied this out, how many x's would we get? 4. We have 1, 2, 3, 4. Alright, in behavior, we know if it's an even, it looks like a parabola, U-shaped. Odds look like a chair. And what causes that to change? Negative split them. So this is a positive, even power, so it's like a parabola. Both ends should be pointing up. Okay, zeros. What would make x minus 4 equal 0? What makes x minus 2 equal 0? What makes x plus 2 0? And why does that one have a multiplicity? Okay, then I want to know, will the graph cross or bounce? How do we decide this? Multiplicity. Even multiplicities bounce. Odd multiplicities go through. Then y-intercept. How do we find the y-intercept? 0 for x. So 0 minus 4 is -4.
Good afternoon, Monroe City High School. There will be a baseball meeting during advisory tomorrow in Coach Rung's room for qualified students interested in boys baseball. Advisory will still meet in the cafeteria tomorrow. This week, Stuco is selling candy grams. You can purchase one for $1 today through Thursday during lunch. Send a candy gram to a teacher or to a friend. They will be handed out during first hour on Friday. Stuco dress-up days